Okay, so for subtopic 3.5 is about series and parallel resistor. So previously we learned about capacitor, right? So it is pretty much similar. So in that regards, maybe kita boleh go through cepat sikit lah. So we have example over here. The one on my left ni, is it series or parallel configuration?
Series.
Kan? So this one is series, so the other one is parallel. So what can I say about the current in series? Current dia apa? Is it equal or? Yeah, so I equals to I1 equals to I2 equals to I3. So basically, as long as there's no junction, basically goes through the same thing. So current will be the same. And then on the other hand, for parallel, so like I told before, if it meet up a junction, then the current will split up. Okay, so you expect if the incoming current, let's say this one is I total, then you have I1, I2, I3. So it will be the sum. So I equals to I1 plus I2 plus I3. Okay, we can put I total, I1, 2. Okay, how about the voltage?
Voltage in series is
Yes, voltage in series is sum, so V1 plus V2 plus V3. So I use this one as V terminal like you learned yesterday. On the other hand, this one is equal for parallel, opposite to the current. Okay. So if I want to derive, I can start with the one with the equation with the plus one. Yeah, the plus tu saya start with that. So in this example, yang plus tu yang kat bawah ni V. So I can substitute Ohm's law inside there, where V equals to IR. So I have IR equals to IR equals to, plus IR plus IR. But since the I is the same, I can cancel out that one. So I left with R. So for series, if you want to calculate the effective resistance, should be R1 plus R2 plus R3. Okay, and then for parallel, we can start with the plus 2. Saya tengok learning outcome kamu sikit. Okay, so for this one, you can start with the plus sign too. So yang I ni, but then you want to substitute Ohm's law, V equals to IR, so I equals to V over R. So this one becomes V over R. Yeah, V equals to IR, so I equals to V over R. So V over R plus V over R plus V over R. So this one is the first one, second, and third. And the voltage is the same, so pretty much cancel out. You left with 1 over R effective equals to 1 over R1 plus 1 over R2 and plus 1 over R3. So most of the time when you try to calculate effective resistance, you might use the parallel or series equations, the two equations. But again, one of the most important parts is the first two tu. Masih boleh kita tengok tu, the properties of current dengan voltage. Okay, ada soalan? Any question?
Nanti dia terbalik dengan kapasitor kan saya?
Yes, dia terbalik dengan kapasitor. That's the easiest way lah to remember. And yang this part yang R effective tu actually is given in the equations, but the two here yang atas ni dia tak diberi dalam equation, so that one you have to be careful lah. Make sure you understand and then shouldn't be a problem. Biasanya kena faham je. Okay, that one is for series and parallel. Maybe you can try to look at some of the examples. This one is question 11. Question 10 is about series and parallel as well, but that one is too easy. I think we can try to look at question B. Yang A ni senang. Kalau A ni kan, katakan saya label this one R1, R2, R3. Saya nak combinekan mana dulu?
R2, R3.
Yes, very good. So that one is simple. So we try to do B, and then A and C maybe you can try to do it yourself. Again, I'm gonna try to show you the best way of doing it lah. If you get a circle like this, first of all you have to label to differentiate between R1, R2, R3, R4, R5, and R6. And so that when you try to solve, you can show the working clearly. Okay, the next part, you identify the junction. So here you have two junctions. One's over here, another one's over there. Okay. And normally I would like to redraw the diagram into something that I'm familiar with. Okay, as example, I will start from the positive terminal there for the 20 volts can. I start from there. So this is 20 volt, the power supply. I'm gonna start from there. And it goes up. Then you make the first resistor. So basically it's from here. Then you make the first resistor. Then the first resistor is corresponding to R1. That's label R1. Then they meet up a junction. Oops, buruk pula. Okay, this junction is the red junction, and then the currents ataupun the wire split up into two. One goes through R2, yang atas tu dia pergi ke R2 yang 7 ohm tu, and then R3, and then R4. And then the another one tu, the red one tu, yang turun bawah tu, dia pergi ke R5. And then both of these meet up at another junction, at the blue junction. Okay, and then it goes out. Oh, pasal ada lagi satu So don't forget to label. So I label that one first. R2, R3, R4, R5. After the junction, you get R6. Okay, and then they end up on the negative terminal. So if you redraw it like this, then it becomes obvious. Okay, the first step that you're gonna do, kau nak combine yang which one? Mana yang nak combine?
R2, R3, R4.
Yeah, so basically you want to combine this part which are in series, so that one is easy. So this is step 1. If you combine step 1, okay, especially if they ask you to find voltage across a certain resistor, and ini dia tak suruh tapi kalau dia suruh tu, you really have to redraw again. So apa yang kamu combine tu, dia akan jadi something like this lah. R1. So basically before you start calculate, you already know what you're gonna do. Kamu dah tahu lah kamu nak buat apa. This would be R2, 3, 4 that you combine just now. You left with R5. Okay, and then ada R6 over there. So still positive and negative. So this is the proper way of doing it. Obviously you can, kalau nak cepat boleh cepat lagi lah. Okay, the next step. Which one you want to combine?
Parallel between R2, 3, 4 and R5.
Yes, very good. So basically you want to combine your middle one here. This would be your step 2. If you do that, so you get the final step, which is so simple. Oopsie. Okay, so you have R1, R2, 3, 4, 5, and R6. Okay, that one will be your step 3. Okay, so to solve that one, step 1, R2, 3, 4 are in series. So R2, 3, 4 would be equals to R2 plus R3 plus R4. So you left with 7 plus 1 plus 10. Should get 18 ohm. Okay, simple kan? And then step 2, you want to combine R2, 3, 4 with R5. So step 2, because that one is parallel ke series kalau yang R2, 3, 4 dengan R5?
Parallel, sir.
Parallel. So R2, 3, 4, 5, 2, 3, 4, R5. So parallel is 1 over. So R5 is equals to 6. So 1 over 6 plus 18. So R2, 3, 4, 5 would be equals to 4 over 18, 9, 4.5. Agaknya lah, kau baca lah. 4.5 ohm. And then the last step
Betul, sir.
bawah ni. Betul Okay. And then step 3. Basically you have the resistors which are in parallel. So R effective or R1, 2, 3, 4, 5 equals to R1 R2, 3, 4, 5 plus R6. So imagine kalau kamu tak pakai subscript tadi, so kamu nak label dengan apa tu? So dia jadi R1 tadi 2 dengan 8. So 2 over here, 8 over there, 4.5. So you should get 14.5 ohm. Okay, you guys clear with this?
Yes, sir.
Okay, good. And then the last step, the next question macam ni lah. So kalau macam ni, kamu nak selesaikan mana dulu?
Yang hujung kanan dulu.
Kan, kat sini kan. Okay. Okay, try to redraw. Kalau kamu redraw dalam bentuk ni, memang nampak obvious lah. Tapi tak redraw pun nampak je sebenarnya. Tapi nak redraw, lagi bagus. Okay, we move on to the next subtopic. Subtopic 3.6 which is about Kirchhoff rules. Kirchhoff's rule ni dia ada dua rules. Rule number 1, rule number 2. Okay. The first thing that you guys need to know is that when you guys need to apply this rule, masa bila nak apply. Okay, syarat dia, you need to have more than one power supply. Dan kalau circuit tu ada lebih daripada satu power supply, then you have to do. Kalau ada student diingatkan, asalkan dia ada dua loop, kena buat. Okay, tapi kalau kita tengok kat sini, we have two loops. Satu loop, dua loop. Tapi we don't have to apply the Kirchhoff's rule. Sebab kamu hanya ada satu power supply. If they put another power supply over here, then you have to do using Kirchhoff's rules. Understand or not?
Yes, sir.
Okay.
I understand.
So, maybe I can try to draw a little bit kat sini kan. So, maksudnya, you can apply it. Mainly lah, biasa you will see that you have like two loop. And then, tapi yang penting sekali sebenarnya adalah more than one power supply like that. Okay, you can apply. Kadang-kadang satu loop, ada dua power supply, you still can apply Kirchhoff's rule lah. Tapi kamu apply yang second rules. Okay, so the first rule, it says that the sum of current entering a junction is equal to the sum of leaving. Maksudnya current yang masuk sama dengan jumlah current yang keluar. Okay, so in terms of formula, the formula will be I in equals to summation of I out. Okay, from my example over here, which current is going in and which current is going out? Mana yang masuk, mana yang keluar?
I1.
I1 is going in, correct? And then I2 and I3 is going out. So just list it down like this. Okay, and I2 lah. So this one occurs at a junction lah. So kamu kena identify junction, pick a junction, and then you can write down the equations. Biasanya kita nak equation yang ni. So this is the concept. Okay. Then sometimes they give you the direction of current. Dalam soalan tu dia dah kasih direction of current tu. But if they didn't give you, you have to decide it yourself. Okay, jadi kita tengok macam mana nak decide. Saya nak cakap lagi tapi saya tak ada kot. First rule tu memang simple, just a simple formula. And sometimes in exam, if you write it like this, if you write it I in equals to I out, sometimes you get 1 mark for the concept. Okay, and then Kirchhoff's rules sebenarnya soalan biasanya markar banyak, dalam 6 pun. So maybe you can get lots of marks over here. So for the second rule, you get the sum of EMF is equal to the sum of the product current and resistance. So what does it mean is that summation of EMF we learned yesterday, EMF kita panggil simbol macam ni, is equal to the sum of the product of current and resistance. Okay, what does it mean is that, let's see if you have, okay, saya tunjuk contoh Okay, maksud kalau satu loop ni EMF gain sama dengan EMF loss. Okay, dia gain dekat sini, dia loss dekat resistor. That's the concept. So maksudnya, let's say this is one, this is I. Sorry. So it's R1, this one is R2, and then you have I1. Yalah. Okay. So maksud dia, summation of EMF is equal to summation of IR. So the EMF part is the one that they gain the voltage potential. The IR part where they lost the potential. So sebab tu dia sebenarnya kat belah kiri juga ni. So kalau dia kat belah kiri, dia jadi tambah EMF tolak dengan IR. Okay. So in this case, you will have, let's say, epsilon 1 sama dengan IR1 plus IR2. Contohnya macam tu. This is example lah. Okay, tapi kita tak tengok details lagi. So each one of these, dia ada positif ataupun negatif. So you have to determine positive and negative to yourself. Okay, macam mana nak tentukan? Dia macam ni. So nanti jadi saya tunjuk satu contoh. Okay, before you start to decide this part, you have to draw the direction of current. Dekat sini kita dah draw direction current, and then dekat this part you have to draw direction of loop direction. Jadi saya explain more lah. And then loop direction dengan current direction ni, dia akan main peranan tentukan whether this one is positive or negative. So the idea is that the blue direction ni adalah loop direction. So in order to determine the direction of EMF, okay, if the direction dia macam ni, dia keluar daripada positif. I'm not sure whether you guys can understand or not. So you imagine kamu tengah jalan kat sini beside the wire, ikut direction of loop ni, you're travelling, and then you're going out from the positive terminal. Going out from the positive terminal, it means that the EMF is gained positive. Okay, and then if you are following the direction to the left ni, again imagine yourself inside the wire, you're walking, and then you're going out from the negative terminal. So this one will be negative. Boleh tak kamu bayangkan this part?
So ulang balik sih.
Okay, saya ulang balik. So dia tengok, okay, we are looking over here. This one adalah kamu punya battery. Okay, this one yang main peranan about yang left hand side ni, the EMF part ni. So we want to determine whether EMF ni positif atau negatif. Okay, so you have to follow the direction of loop. Loop direction ni kamu yang tentukan. Okay, let's say kamu tentukan dia ke kanan. Yang bawah ni kamu ignore dulu. You just want to focus yang atas ni. So we decided that the loop direction is in this direction. So referring to the EMF over here, it is actually going out from the positive terminal. This is the loop direction going out from the positive terminal. So it is positive EMF. Okay. Kalau dia going out from the negative terminal, macam yang bawah ni, let's say you determine direction of loop to the left. So it goes out from the negative terminal. So that means you have to put negative epsilon.
Oh, faham.
Faham? Okay. Now, adakah suara saya tersekat ataupun memang Syafiq itu saja?
Saya dengar okey je.
Okay, mungkin Syafiq punya lain kot.
Sorry,
Okay.
yang panjang tu positif, yang pendek tu negatif.
Yes, yang panjang tu positif, yang pendek tu negatif.
Okay.
So dia ikut terminal battery tu lah. Okay, Syafiq, don't worry, kalau kamu miss out anything nanti later kamu boleh dengar balik lah. Saya record this one. So this one is positive terminal. Oops. And this one is negative terminal. So dia ikut terminal mana tu, dia keluar daripada mana. Okay, now itu yang about the left hand side. Okay, and then on the right hand side you have to use a different concept sedikit. Okay, now you need to know the direction of current. So direction of current ni saya draw pakai red. Direction of loop tadi tu saya draw pakai blue. Okay, if the loop and the current direction is in the same direction, this one will be positive. Okay, if the loop is in opposite direction, opposite, this one is negative. Okay, so I'm gonna write down over here as same direction. This one is opposite direction. Okay, it's nothing to do with whether dia ke kiri ke kanan. It's just that whether it is in the same direction ataupun opposite direction. Later on, I will give you an example. Maybe you can see clearly. But for now, boleh nampak ke tidak? I mean, can you guys
Boleh, boleh.
understand a little
This
bit?
one is
Boleh,
easier lah daripada tadi.
Yes. Okay, now we try to do one example. Kita can start with the question 13A. Okay, 13A, they give you a circle. And then you can see that there's two EMF, and from the diagram itself you can see there's two loop. Ada dua circuit yang bersama, dua loop lah, dua gelung. Loop bahasa Melayu gelung kan. So if I want to redraw, basically normally I would like to redraw yang tengah ni, I don't like it to be diagonal. Saya tak suka di diagonal. Instead I prefer to be square, macam square. I try to redraw first. Okay, so basically this one adalah same circle, just that I redraw it. Okay, so that one will present the 6 volt to label it straight away. EMF 1, 6 volt. Okay, then EMF 2 is 9 volt. And then you have 8 ohm over there. Let's say I put this one as okay, jadi saya label berapa, terfikir lagi, 8 ohm. And then okay, I label R1 lah, put R1 over here, and in the middle there the 18 volts, sorry, 18 ohm. And then you have 12 ohm over there. Okay, sama ke tidak dia punya circuit tu? Adakah circuit dia berubah? Or is it still the same? Yes,
Sama-sama.
sama kan? Okay, dia masih sama, just that saya rearrange dia supaya dia nampak lebih kemas. Okay, the first step yang kamu boleh buat adalah you can identify direction. Sorry, you can identify loop 1 dengan loop 2 tu dulu. Okay, maybe kalau dalam exam biasa saya suruh student saya warnakan kamu punya loop tu ikut different color. So, maksudnya this would be my loop 1. So anything that touch the red line is basically my loop 1. Okay, then maybe I can choose another color. Then this one will be my second loop. So you can see that R2 tu dia bertindan. Dia ada dekat loop 1, dia ada dekat loop 2 juga. So memang macam tu lah. Okay, so this would be my loop 2. Just now we do is loop 1. Okay, so far you guys okay?
Okay, sir.
Okay, and then you can see ada 2 junction. So maybe you can label those junction. Saya di biru, saya lagi satu saya label biru cair. Okay, nanti bila kamu nak selesaikan, kamu fokus kat satu junction je. And then the next step is that you have to determine the direction of loop. Okay, loop direction dulu. Loop direction ni, if you want to determine, biasanya saya akan ikut EMF. Okay, so you have 2 EMF, epsilon 1 and epsilon 2. So between epsilon 1 and epsilon 2, which one is bigger? Nilai apa yang lagi besar?
Yang itu, yang epsilon tu.
Epsilon 2 is bigger. So basically I want to draw my loop direction ikut epsilon 2 tu. Maksud ikut tu, saya nak epsilon 2 tu positif. So dekat bawah sini it should be to the right ke to the left kalau dia nak positif epsilon tu.
To the right.
Right, okay, very good. So this one is a loop. So dia basically pergi sini, ni atas, dia pergi sini, so dia turun balik. So this is your loop direction dekat loop tu. Okay, kenapa saya buat yang situ? Saya pergi dekat yang EMF paling besar, saya ikut dia. Okay, the reason kenapa buat benda ni, so that bila saya selesaikan, I will have lots of positive numbers instead of negative. Okay, that's the main reason lah. Let's say if you decided it to be in opposite direction daripada yang saya buat ni, tak ada masalah, you still get the final answer correctly, don't worry. It's just that you will see lots of negative numbers when you try to solve it. Okay, so between these two loop ada satu jalan yang sama kan, despite direction dia sama. Okay, the key thing on how to solve this one easier, the easiest way to solve lah, make sure yang loop 1 ni dekat tempat yang bertindan ni direction dia sama. So it is to the left as well. Okay, so far can you guys follow me? Masih bersama saya?
Masih.
Okay, good. Okay, I try to go as slow as possible so that you guys can follow. Okay, ada satu book, maybe your notes pun sama kot. Nota dalam loop direction tu dia biasa buat macam circular, something like this. And then something like this. Sama je. Basically kat tengah-tengah ni nak sama direction lah, itu biasanya. Okay, the reason kenapa saya tak lukis circular tu, so biasa bila saya lukis circular tu, student dia tak nampak dekat atas resistor tu direction of loop tu ke mana. So I decided to use macam squarish punya direction. Shape tu macam squarish. Okay, apa tadi? After that, once you determine the direction of loop, you have to determine direction of current. Okay, direction of current ni sometimes it is given inside the question. Kalau diberi dalam soalan, you have to follow lah. Katakan dia kata I1 is in that direction, so you just have to follow. But in this case, you didn't see any direction inside the question, so you have to label it yourself. Okay, so I choose one junction, pilih satu junction. Let's say saya nak buat junction yang kat bawah belah kiri ni, yang biru pekat tu. So if I want to choose, basically again, kalau nak dapat kurang negatif, ikut direction of loop. Okay, and then labeling, sebab yang tu R2 kan, so saya label sebagai I2. Okay, and then maybe it goes out over here. This one is your I1 and this one is I3. Sorry, this one is I3, this one is I1. Kenapa saya tukar? Sebab saya lagi nak label between R dengan I. So kalau dia nombor yang lain, dia tak ada masalah pun. Just that kamu takut confused. Okay, so far can you guys follow?
Boleh, sir.
Okay, so direction of current ni again, it doesn't really matter where do you choose. Tak kisah kamu nak ambil dia terbalik ke apa, it doesn't really matter. If you choose it in opposite direction, the final answer for your I, you will get a negative value. Negative values mean it is opposite to the initial assumption. Okay, contoh yang saya dah kira-kira dapat I tu ni negatif. So that means actually the actual direction of current is actually to the right. Dekat sini. Itu je maksud dia. So you don't have to worry. Buat je mana-mana. Loop direction tak kisah, current direction tak kisah. As long as kamu buat, lukis, fixkan dia. Jangan berubah-ubah. Okay, now dah lukis everything, dah lengkap, you can try to solve. Then only you apply the first rule. So the first rule say summation of I in is equal to summation of I out. Okay, so we are talking about the one with the apa ni, dark blue ni, junction dia. So in dia adalah apa? Out dia adalah apa?
I2 in.
I2 is in, I1 and I3 is going out. Good. This is your first equation. Okay, but then if you want to solve this one, sebab dia ada kamu akan ada 3 equations now. So if you have 3 equations, the best way to solve it is using your calculator. So dalam calculator nanti saya nak kamu tekan macam the matrix. So calculator kamu buat matrix lah. So maybe you can rearrange, you put everything with the pemala I ni, kamu bawa dia ke kiri. anything without to the right. So here I just bring everything to the left. So you have negative I1, okay, positive I2, negative I3 equals to 0. Okay, ataupun kamu boleh banyakkan positif, kurangkan negatif, you bring everything to the right and then kamu flipkan dia sama je. So you can do this one as I1 minus I2 plus I3. Okay, this will be your first equation. The second and third equation pun try to rearrange dalam form ni. Mana-mana ada I, letak satu side, yang tak ada I, one side. So now you want to apply the second rule. The second rule states that summation of EMF is equal to summation of IR. Okay, you can start with loop 1 first. Okay, according here, over here in loop 1 is the red punya loop. So basically when you try to solve this one, kamu boleh ignore lah loop 2 ni, jangan pandang pun. Okay, ada berapa banyak EMF dekat loop 1?
Ada 1.
Ada 1. Resistor ada berapa?
Resistor ada 2.
Yes, very good. Okay, so now you want to determine dia ada epsilon 1. Kan, epsilon 1 ada. Lepas tu kamu ada R3 yang correspond to R3. Basically ni R3 dia just jalan benda sama kan sebab dia tak ada junction. And then R2 that correspond to I2. Ada tiga benda lah. So I can write down like this. Epsilon 1 equals to I3 R3 I2 R2. Okay, notice that I didn't put any sign convention yet, and because you have to determine yourself lah. Okay, for epsilon 1 ni, loop direction is the purple one. So the one that matters is over here. This is the direction of your loop. This is your terminal. So is it positive ataupun negative EMF?
Positif.
Positif ingat lagi kamu macam dekat dalam wire ni, you travel, bila kamu keluar dekat sini, you goes out from the positive terminal. So this one is positive. Okay, good. So EMF 1 is positive. So I just put it here as positive. Tak letak pun tak apalah. So positive. Okay, I3 R3. So I3 tadi saya lukis balik. Okay, this one sebenarnya benda yang sama. Dia travel from there in that direction and then masuk kat sini. So this one is actually your I3. Okay, to determine the sign convention for across the resistor yang IR tu, kamu kena tengok dua benda lah. Between direction of current dengan direction of loop. Same direction ke opposite direction? Ni same lah kan? So positif ke negatif? Naik balik. Kalau same direction, dia adalah positif. Faham ke tidak?
Faham saya.
Okay, and then for R2, positif ke negatif? Cuba orang tengok. Kalau dekat sini pula. So basically you just want to refer to this diagram lah, this part. Positif atau negatif? Loop direction ke mana? Current direction ke mana? Purple dengan green. Same direction ke opposite direction?
Same direction. Positif.
Same direction. So positive, very good. Okay. So this one is positive as well. So the fact that you get lots of positive is not coincidence. Sebab apa kamu dapat positif tu? Sebab kamu memang buat loop dengan current direction tu accordingly. Ini ikut macam yang saya cakap tadi lah. Sebab tu dapat banyak positif. Okay, now masukkan nilai. So that one is 6. Okay, and then R3 is 12. So 12 I3 and then 18 R2. So you can bring everything, sorry, I2. You can bring everything to the left. Yang ada I, yang tak ada I, you put it on the right. Okay, basically semua positif kan. So you get 12 I3 18 I2 plus 0. I1 is 0, so I just put 0 like that. Okay, this one would be your second equation. Okay, and then from loop 2, I can use the same concept, just that now I focus on the second loop, the yellow part. Okay, so ada berapa banyak EMF over here?
Ada 1.
1 EMF, epsilon 2, resistor ada 2, R1 dengan R2. So R2 ni yang lalu dia adalah I2, R1 yang lalu dia adalah I1. Okay, kalau let's say kamu label ni I1, so you have to do I1 R2. Tak kisah pun, betul je. Epsilon 2 R2 dengan R1. So we have epsilon 2 I1 R1 I2 R2. Okay, epsilon positif ke negatif?
Positive.
Okay, loop direction to the right. It goes out from the positive. So the positive. Okay, very good. Okay, across the first resistor, resistor 1 over here. Positive ke negatif?
Positive.
Yes, current direction downwards. Loop direction downwards. Therefore, it is a positive, same direction. And then the last one is this one. Loop direction to the left, current direction to the left. Therefore, positive and negative.
Positive.
Yes, very good. So R1 is 8, R2 is 18. And the epsilon is equals to 9. Okay, again, I rearrange. I can bring this one 8I1 plus 18R2 plus 0 equals to 9. This would be my third equation. So if I have 3 equations, I can bring everything on side by side to compare. Okay, like I told you before, try to write it in metric so that it is easier when you try to solve it using calculator. Okay, from this one, cara nak selesaikan, kamu tahu tak cara nak selesaikan? Switch on your calculator.
Pakai metrik sir.
Yes. Tekan mode, tekan equation, tekan 5. Saya punya ni 5 lah, kemudian saya tak show. Tekan equation, tapi ambil equation yang ada di X, Y, Z dengan yang belah kanan tu adalah pemalar. Saya ni nombor 2. So you get a matrix. This will key in. So the first part ni kamu key in lah. Kalau yang ni 1, negatif 1, 1. Cuba tekan 1, negatif 1, 1, 0, 0, 18, 12, 6, 8, 18, 0, 9. Okay, I end up with X sama dengan 27 over 76. Dapat 13 over 38. And then negative 1 over 76. Okay, the XYZ to correspond to I1, I2, and then I3. Okay, dapat sama ke tidak?
Dapat sama.
Sama. And normally you would like to write this one in terms of decimal point lah. I got 0.355, 0.342 ampere, 0.013 ampere. Okay, just double check the answer. Okay, the magnitudes are the same. Cuma ada positif dengan negatif je. Macam kat jawapan tu ada negatif kat negatif 0.013, negatif 0.355. So what does it mean? So this is the answer, this one. So what does it mean? Kalau yang negative 0.013 ni, maksudnya dekat I3 ni, our initial assumption yang dia ke atas is actually misleading lah, salah. Dia sebenarnya adalah ke bawah. Okay. Kalau dia tanya direction, then you can answer lah. Sometimes dia tanya direction of current dekat atas R3 ni. Contohnya macam tu. Tapi dia tak tanya. So it's either you can leave it like this ataupun kamu boleh remove the negative. It doesn't really matter. Bila pemeriksa tanda, they're just referring to the magnitude. Understand or not?
Yes, sir.
Okay. So saya ulang dia memang panjang sedikit. Yang the key thing here is that bila kamu redraw ni, kamu kena identify loop 1 dengan loop 2. Okay, and then the paling penting sekali, determine the direction of loop dengan current tu. Kalau current tak diberi lah. After that, you just follow the flow. So loop direction and current direction ni, if you choose it properly, you get something like this. Lots of positive number. Semua positif, semua positif. Kalau kamu buat terbalik, you get lots of negative number. Again, tak ada masalah pun. So the final answer, you should get the same answer. Magnitude dia mesti sama. Cuma maybe ada negatif kat tempat-tempat lain lah. Macam tu. Okay, ada soalan ke tak untuk Kirchhoff?
Tak ada, sir.
Okay, there's no question. We're moving on to the last topic that I want to show you today. Okay, the last one is about 3.7, electrical energy and power. Okay, for power you have three main formula lah. P equals to IV, and then from there you can derive some more daripada equals using Ohm's law you can get P equals to I squared R and P equals to V squared over R. Tak kisah nak pakai mana-mana. Tapi kalau kamu tengok dalam nota kamu, dia try to differentiate lah. Iaitu kalau power loss ni across the resistor. Kalau yang power supply dia pakai yang IV, tapi bagi saya sama je. It doesn't really matter pun. Mana-mana nak pakai, tiga-tiga boleh pakai. So the unit for the power will be in watt. This sebenarnya adalah power by definition is equals to work per second. So power sebenarnya adalah work per time. So joule per second. That joule per second is what we call watt. It's a scalar quantity, so you don't have to worry about the direction. So in terms of electrical energy, is basically the work done lah. So work equals to P multiplied by T. Power times time. And then if I substitute my first part over here, I should get IVT. Okay. Kita cuba tengok example. Dia kata sini, a toaster is rated at 600 watt when connected to a 120 volt source. Calculate the current that flows through the toaster, total resistance of the toaster. Okay, yang 600 watt tu simbol apa kita nak represent?
P.
Yes, P. Yang 120 volt source tu?
V.
V, correct. Soalan satu nak apa? Current, so I. Soalan dua ni nak R. So senang so if you want to get I from P dengan V, you can use formula P equals to IV. Okay, saya ambil copy lah formula. So this formula, these are the formulas. So you can see that 600 is equals to I 120. So I is equals to 5 ampere. Okay. For question B, they want to find the total resistance. So you know that P is equals to I squared R. So saya memang suka pakai formula ni Therefore, 600 equals to 5 squared R. This one is 24. Okay, dapat tak?
Dapat, sir.